What's up, everybody? Let's tune into a new episode of Math Relation. Most people, if you're in algebra right now, we're still in the section of polynomials. Your only thing now is we're going with factoring. So, up to this point, we have been building expressions. We've learned to combine like terms, if that's adding or subtracting, same variables, exponents that align with each other. We learned how to multiply polynomials, and we also have expanded what we needed to collect. So factoring is nothing new. Essentially, truly what factoring is, it's the same word, just in reverse, right? So I want you all to write this on your paper, and I'm gonna write it with you. So everybody got to have their notebooks. We're gonna do our scheduled notes. We're gonna say what factoring really is. And to ask this, we're going to start off with this one question. What pieces had to exist to create this expression? What pieces had to exist to create this expression? Multiplying tells you a story forward. Factoring is now telling you a story backwards. So it's going to be in this loop. Multiplying brings you forward, factoring brings you to the beginning. Just like that. So for those who might need that extended help or make it make sense a little bit further, right? You cannot factor what you do not understand. So let's make sure we all are on the same page of understanding. Because if you do not know what exists, you will not know what you could have created. So that's why count check is something that we put in our places. So I'm going to have you all write this down. 6x squared plus 9x. So everybody's paper should be right here. 6x squared plus 9x. Now we know that is a standard setup. For a lot of us who need visual learning, I got you. X squared, x squared, x squared, x squared, x squared, x squared. 1, 2, 3. 1, 2, 3. 1, 2, 3. So here we go. We got a lineup of 6 total x squareds. 1, 2, 3. And then we got to set up again. 1, 2, 3. And then now we got 1, 2, 3. 1, 2, 3. 1, 2, 3. Now, what you're going to notice here as we did that. Actually, I got to erase my 1, 2, 3s and make those be x's. I apologize. If 9 was constant, then that'd be the perfect setup. We got to do 1, 2, 3 with our x's. So there you go. It should look like this. Apologies for that correction. So as we look at this, right, what do they all have in common here? I can't combine like terms, but what do they have in common here? There's only one variable that everybody should see, and that should be x. But not only is it x, you want to say, well, 6, 9. If I was to increase from 6 to 9, I know that's going by threes. So if I was to go backward, 9, 6, 3, I also got factors of threes. And they also share x. So we're going to say what they have in common, 3x. So let's try that out. If they both contain 3x, That must be our greatest common factor. So if I could take out a 3x and I compare it with 3x gives me, now we get to work on a multiplication table, so all of this comes full circle. That's why I love polynomials. It's a great standing for any student in algebra. You get you right at the beginning of the new year. You can say halfway mark. But if you don't know, this is a time where you truly have to speak up or the work is going to show for it. And for a lot of students who face it on tests, you find yourself getting 35% to 60% range. But yeah, for the homework, you're scoring in those hundreds, right? We all know. We're using ChatGPT, AI, Gemini. We all know. But let's really get to knowing this. It's cool, you can use that as your assistance, but if you're always relying on it, you're doing yourself a disservice. Math doesn't work like that. But that's why we're here. So with 3x, you want to apply 3x to say, okay, 3x times what gives me 6x squared? 3 times 2, and then I know x times x using the x squared as we worked on with multiplication previously. So I'm going to put 2x here. And 3x times what gives me 9x? Simply 3. So what you're going to write is 3x, and then inside your parentheses is 2x plus 3. So this is what we started off with multiplying to get to where we need to be. Factoring now is saying the end of the story. How do we get back to the origin? We've been working on the origin of the story to get to the end. Now we're going backwards. But for people who might need to say, okay, what does that look like? So we're going to take 3x, distribute it to 2x, which gives you 6x squared. 3x, distribute it also to 3, which gives you your 9x. Voila, magic. But let's keep it going. It's not a trick. And we didn't guess. We pulled out what was every term shared. That's what factoring is. So that's what your count check is going to do. So your job now, we're going to say factoring. Let's talk more about factoring. Because before we can really do math, we got to understand the relationship we're getting ourselves into. So factoring, let's put some more to it, right? We're going to say factoring removes what is common, multiplying adds what is shared. Same relationship. Opposite direction.
Switch to TurboTax and file your own taxes free in the app if
Nope.
you didn't file with us last year.
All right. That's what we got on our paper so far. Factoring removes what's common. Multiplying adds what is shared. It's the same relationship, yet opposite direction. Let me make sure I'm writing clearly. Come on, Jackson, you gotta make sure you're writing where it's legible for everybody, not just for yourself. So, as much as I love to be how great I am, I'm not always perfect. But here's what we're gonna do. Let's go back to our 6x squared plus 9x. And let's talk more about this relationship. We broke it down where we can say, hey, I can get a 3x out of it all. So that means we can group. That means we are not dividing randomly. This has to be strategic, and it has to make sense. So, division is done with intention. We are reorganizing So, whenever you see factoring, I want you to think of it like this. This is the language you're going to use. What can I pull out and still leave everything else whole? What can I pull out and still leave everything whole? What does that mean? So if removing something is to break the unit, that means it doesn't factor. Per se, with that 6x squared plus 9x. What if I said, well, 2 is factorable of 6 in x. If I took out 2x, I can say, yeah, 2 goes with my 6x, but does 2 go with our 9? We're trying to force something. Whenever you force something, you come into problems. And if you don't see the problems then, you will see it later. So, what can I pull out and still leave everything whole? Let's take that to a case like this. Anybody remember this? X plus 5 and x plus 2. What we're going to do here is we're going to use our famous word, crack. A lot of us know FOIL, but let's go with crack, because we're going to crack these numbers wide open. We know x times x gives us x squared. We know x times 2 gives us 2x, as well as 5 times x gives us 5x, and 5 times 2 is 10. So we have 4 terms, which means we need to make sure we also have 4 lines. Then we're going to combine our like terms with our 2x plus 5x, which gives us the infamous 7x. But I did something here. I told you how multiplying is what's telling the story. Factoring is saying what the ending was and how do we get back to our origin. So we're going backwards. So check this out. If I have x squared plus 7x plus 10, and if I go backwards, meaning if I go from bottom to top, I see an x squared and I split that up with 2x plus 5x, and then I have 10 on my end. But if I go up one more, I see a pair of x's that shows x and x. I see 5 and I see 2. When I did 5 plus 2, I got 7. Yet when I did 5 times 2, I got 10. There's a story here. I know that 5 times 2 gives me 10, and yet 5 plus 2 gives me 7. Which, if I write it like this, I see that they're both shared in common right here. 7x, 10. I know x squared is the result of x times x. So if I was to factor these and put these together, I say, well, for me to get x squared, that's the result of x times x. For me to get 7x, that's the result of 2x plus 5x. And on these two numbers that I had just added together, if I multiply 2 and 5, that gives me 10. We got factoring, ladies and gentlemen. We have got factoring. So what I want you to do is, you're going to say factoring asks what two expressions would multiply to give me my end result. And these same two expressions, when they add, or essentially combine like terms, give me my middle result. We're on to something. Let's try this out. So, most people will say that is what you call the product. And if you struggle with product means multiply. Sum is the result of addition. So if I'm rebuilding a structure, we're solely going to stick with that x squared plus 7x plus 10. For me, cracking it open, that is x and x. When I multiply, remember, two x's together, I add the exponent and I get x squared. X is now being multiplied to 5, which gives me 5x. X is multiplied to 2, which gives me 7x. When I combine those like terms, right, when I rearrange what needs to be aligned, that's 2x plus 5x, which gives me 7x. And then I do with the end result, 5 times 2. 5 times 2 is 10, which is my end result. I now created a trinomial, x squared plus 7x plus 10. So factoring validates multiplication. Let's write that down. That's a good one. We're going to put that in quotes. Factoring validates multiplication. For everybody that's tuning along, this is how our notes are looking so far. We got stuff that's set up nice, neat, and we can get even more further organized. That's the beauty. See, when you have language with math, I gotta put y'all on to some of our new stuff that's coming out. It's called Numera. She speaks the language of math. So all the ladies out there, our women scholars, our STEM ladies of excellence, get ready to rock Numera. She's got all this nice shirt. It's gonna say math relation on here. It's gonna be crazy. They're gonna go to school and everybody gonna be like, "Ooh, what's that?" Don't say I warned you. But let's keep it going. Let's try something a little bit more challenging. Let's say I have a number. Let's say I got a trinomial already in play. 6x second power plus 11x plus 3. Everybody write that down. We got a trinomial in our hands. We're not going to add it. I'm not going to put this in parentheses to add it to another one, let alone subtract it. We're going to focus solely on this right here. We're going to say, okay, what do I notice for here? Let's label it A. We're dealing with letters, so let's start with our alphabet. A, let's call our middle one B. Let's call our third one C. A, B, C. It's easy like 1, 2, 3. So when you're going about it this way, I gotta say, what's the results that I get with A? Well, I got 6 and I got x squared. I normally would say x times x, but I gotta say, okay, what number gives me 6 if I'm still going at it that way? But then I also have a number for C. We were discussing x, right? And the thing about x is an x makes a line. Two lines. And sometimes our lines do something that's pretty interesting. Because if I label this A, B, C, I'm going to notice something. I'm going to notice that my A crosses over as well as my C crosses over. And they make an operation there. Which operation is an x? Multiplication. So let's try 6 times 3. What happens if we manipulate our trinomial to something even greater? So let's do that. Let's do 6 times 3. Let's make a rule. 6 times 3. If we have a number where I see I can't factor it evenly, we're going to multiply the number that represents A by the number that represents C. So 6 times 3 gives me 18. And I'm going to now rewrite this. I'm going to say this is now x squared plus 11x plus 18. Let's go back to something that we looked upon with our last problem. Let's evaluate x squared. I know x squared is a result of x and x. Great, let's bring that down. My middle result is 11. Okay, what all numbers equal up to 11? But before I do that, I got to look at my C to say what numbers multiplied by each other give me 18. So I know 1 and 18, but I don't want to do that. I know 2 and 9. Oh. Well, 2 times 9 is 18. 2 plus 9 gives me 11. Let's try it out. So on your paper, so like this. And we can keep going down the tree just for the sake of it. So 2 and 9. Is 4 a factor of that? 4, 8, 12, 16? No. 6, 6, 12, 18. Oh, yeah. So 3 and 6. But 3 and 6 add up together, give me 9. I need 11. So we're going to focus on x, x, and 2, 9. Let's see what happens if I put those in a pairing. X plus 2. Make that a parentheses. X plus 9. Make that a parentheses. But now what do I do with this 6? What do I do with this 6? That is the question of the hour. So I'm going to put y'all on to something advanced. Because remember, we multiplied everything in the beginning, A times C. We kind of just did it out of nowhere. We just said, hey, I got a rule for you. So if I do that, let's go back and take our A. And what we're going to do now is I'm going to pair it. I'm going to say, hey, Mr. Jackson just told me that multiplying tells a story. Factoring, which is division, is going to now give me the recap, saying the backstory. So if I just multiply first by A, what if I now do the opposite and divide by A? Let's see. Let's write this down on our paper. Let's go rule. A times C. Rewrite the trinomial. Factor. So B is the multiples when added to get C. Now, when paired, let's divide / reduce by 8. So here's what I'm writing. This is what's being defined. I just wrote x plus 2, x plus 9. Why? Because when I did my rule of a times c, I got 18, which is above. I rewrote my trinomial, x squared plus 11x plus 18. And then I factored, so my b is the multiple. Well, my b is what is the multiples when added to give me c. So 2 times 9, 3 and 6, but I need to make sure my b is what's equal to what my multiple is. So 11, which one is my multiples? 2 and 9, 3 and 6. All right, I got my multiples, right? My multiples. Now I go, hey, 2, 9, I multiplied everything originally by 6. So now let's divide it. Let's reduce it by a. Let's divide this by 6. Let's divide this by 6. If I can't divide it, well, hey, we're factoring for a reason. Let's reduce it. 2 and 6, what do they have in common? 2. 2 can be divided by 2. 6 can be divided by 2. This results in me getting a x plus 1 over 3. What's that gonna sound like? Then I have an x plus 9 over 6. Let's see, I can reduce all of those by 3. That gives me x plus 3 over 2. So now we're looking at something like this. X plus 1 in the parentheses, x plus 3 in the parentheses, but below I got a 3 and I got a 2. Mr. Jackson, what are we doing here? I thought we were just doing simple math. You hearing these kids right now. They're following along. You don't know what the heck is going on. Just follow me. I got you. So as we put those numbers in our denominator, we're going to attach them to the x that they're paired with. So I'm going to make an arrow and direct you exactly where that is. So this gives you 3 is going to bolt to x, 2 is going to bolt to x. In football, we call that a post, but really it's a slant. But we're going to slant, or we're going to post ourselves to x. So now I got 3x plus 1, 2x plus 3. Let's see what happens when we multiply that bad boy. So 3x times 2x, that gives me 6x squared. 3x times 3, that gives me 9x. 1 times 2x, that gives me 2x. 1 times 3, that gives me 3. We're cracking. 6x squared plus 9x plus 2x plus 3. What's my like terms? Focus on the middle. 9x plus 2x gives you 11x. And holy boly moly doly coly, something needs to rhyme with holy, because we just created our original problem. So that means when I factor 3x plus 1 and 2x plus 3 is my factoring. Because when I just multiplied them, it just got me right back to my original standing. Ain't no way. Ain't no way. So we gotta add ourselves a little something right here to say, how do we do this? So when we divide it, or reduce, when we reduce, the numbers inside our binomial, or parentheses, we take the remainder and attach it to x inside the same parentheses. Let's not confuse ourselves. We do that too much with overthinking. When we reduce the numbers inside our parentheses, right? That's right over here. X plus 2 over 6, x plus 9 over 6. We reduce those numbers. 2 is divisible by 2, 6 is divisible by 2. 9 is divisible by 3, 6 is divisible by 3. So I got x plus 1, x plus 3. I reduce those. My remainder with 6 and 2 was 3. My remainder with 6 and 3 was 2. So I said, hey, when we take the number, take the remainder now and attach it to x inside that same parentheses. Don't do anything else. So that's how we got this. It says 3x plus 1, 2x plus 3. And just in case, if I want to make sure it's all right, I multiplied them. So I cracked it. 3x by 2x, 3x by 3, 1 by 2x, 1 by 3. And what do you know? 6x squared plus 11x plus 3. Same thing up here. Whoop-de-doo. Sounds like you're right to me. This isn't random. It's structured. Once you understand structure, it all comes together. I promise you it all goes together. It's like a new operating system being developed in your brain. You're downloading the newest version of I understand math because it's relatable. Math relations just made it make sense. Y'all gotta pay me for this, man. Y'all gotta pay me for this. Y'all didn't know y'all had a math teacher who probably is a musical artist, you know what I'm saying? I put words together that get you. Let me stop. So, multiplication builds the structure. Factoring reveals the structure. I promise you, bro, y'all don't understand. What y'all do understand, y'all listening. Okay, so multiplication builds the structure. Write that down. And factoring reveals structure. This is coming home from the 9, the academies that makes it fun. I want to do another one of these, and we're going to go backwards. We're going to start from what we just finished. We're going to go back to what we did on our previous page, and then what we started off from the first page. So we went 1, 2, 3. Now we're going 3, 2, 1. So I'm going to do another example like how we did with our 6x squared plus 11x plus 3. So multiplication builds structure, factoring builds structure. Leave my handwriting alone. Yours should be better than mine because I'm telling you, you got captions to follow and you could go backwards to hear exactly what I said. So leave my handwriting alone. They say geniuses write a little, so I've been a little. But I know some of y'all got some worse handwriting than me, so don't even be talking. So I got, let's go with 2x raised to the second power plus 7x plus 3. And let's go back to our x rule. Let's go with a times c. So a times c. We're going to do 2 times 3. So here we go. I want y'all to think it through. See if you can beat me. 2x squared plus 7x plus 3. I did a times c, which is 2 times 3. So that means I'm going to rewrite this to now say what, people? You're going to say what, people? Look at what we did up here. What do we do up here? What do we do up here? Go back to your notes. Go back to your notes. They're notes for a reason. What are the notes for your reason? Right after this rule, a times c, what do I need to do? Rewrite the trinomial. How did I rewrite it? What did I get here? So what else is left? So x squared plus 7x plus 6. You need to factor. What are my factors of 6 now? Factors of 6 that add up to 7. Well, I know 2 times 3, but 2 times 3, 2 plus 3 gives you 5. I need 7. So what's that prime number? 1 times 6. 1 plus 6 gives you... Let's do it. X plus 1, x plus 6. Now we're going to take our 2 and say, hey, can I divide 2 by 1? Can I divide 2 by 3? Now, 2 cannot go inside of 1. 2 can go inside of 6. Gives you 3 times. So you're going to have x plus 1 divided by 2 and x plus 3. So we follow what is shown. We just got to this part right here. We just rewrote everything. We said we need the factors, so our b is equal to the multiples when added together to get c. So 1 and 6 gives you 7, correct? All right. Now it says we need the pair. Now when paired, let's divide or reduce by a. So here I said, all right, let's divide our 2 by 1 and 6. 2 can't go into 1, so we're going to leave it there. You know what that means we're going to do now with 2. 2 goes inside of 6 a total of 3 times. So there we go. What's left over? What do I need to do? Let's go back here to our notes. What do we do here? When we reduce the numbers inside our parentheses, we take the remainder and attach it to the x inside the same parentheses. So here I go. I got 2. Do I move it over here? Is this the same parentheses? Nope. I attach my 2 right here. So I'm now going to rewrite this to say 2x plus 1 and x plus 3. Let's start cracking. Let's crack it open. 2x times x gives me 2x squared. 2x times 3 gives me 6x. 1 times x gives me 1x. 1 times 3 gives me 3. Something's adding up here. 2x squared plus 6x plus 1x, that gives me 7x. And then my plus 3. Oh, snap. Your favorite teacher just made it. I was about to say something, but your favorite teacher is black. I said it. Your favorite teacher is black. Oh, it's too much Dave Chappelle, man. All right, so we put this together, man. You got 2x squared plus 7x plus 3. And there we go. So our factoring is going to be 2x plus 1 and x plus 3. So let's go ahead and let's box those. All right, let's go to a new problem. Let's go with x squared plus 9x plus 20. So here, new problem. But guess what we're going to do? Because we did some work already. Let's go back to our notes. Let's go here. Let's go to the part where it says language. What can I pull out and still leave everything whole? What can I pull out and still leave everything whole? So 20. Let's just start all our factors of 20. Factors of 20 that must add up to 9. 1 and 20 gives me 21. 2 and 10 gives me 12. 5 and 4. 5 plus 4 gives you 9. Alright, so x plus 5, x plus 4. Multiply those bad boys now. X times x is x squared. X times 4 is 4x. 5 times x is 5x. 5 times 4 is 20. Looks like we have ourselves a winner. I might have went a little faster because I'm starting to get the flow. But maybe you are too, so it's only what you know. Ooh. And then let's do another one like how we started it off on this page. We got ourselves up here, right? Boom, boom. So let's try that out. See if I can make it all work before I twerk, my leg, work, my leg, work. Let's go with 4x squared plus 8x. They both share a x squared. And then I got sets of 8. So if I put those in pairs of 4s or groupings, starting to catch on to something. So I did that here. 4x squared plus 8x. I got a total set of 4x squares, and I got a total set of 8x's, and they're paired by 4s. Look at that. What do they have in common? I just put what numbers are all of my x's ironically lined up as. 1, 2, 3, 4. What variable do you see consistently? X. Let's take out 4x. Make our job simple, baby. 4x. 4 times what? Well, x. Leave that there. 8x. 4 times that must be 2. So that's 4x parentheses x plus 2. Boom. We done. We winning. It's done. It's over. It's begun. Now we rapping for fun. Okay. That's a good lesson there. I should give y'all some homework. But what you realize is factoring is not guessing. There was no guessing going on. It's solely understanding where the expression came from. Just like you all. As you're listening to this, you're a student, parent, teacher. Everybody came from somebody. Mother, father. The world's trying to expand and say you came from a nucleus. But I digress. Math, we can prove it. If you can build it, you can break it apart. We just broke something apart, then we put it together. We put it together, we broke it apart. Multiply, factoring. Factoring to multiply. It's all gonna make sense. It's the reason why we got plus minus, because I can add something, and that means I also can take it away. If I can take something away, I know it needs to be added to create the balance. The same rules apply with multiply and divide. 2 different operations, but they give the same sequence of what follows. So, let's look at, I'm finna take this out the park. You know how your rappers be dissing each other? Let's go ahead and let's beat this one up, right? So this is the Algebra 1 book. I think people already get a math relation book. Ooh, that'd be so hard. That'd be so hard. Look at this. This is not swag at all. This is not swag at all. But y'all finna get the whole math relation book. So for people that's learning algebra and people who are going to begin learning algebra, want to prepare, get ready for the math relation book. Let's take one of their problems. Let's see. What they gonna throw at us? What they got? Bring the gap. Where I'm at. Bring the gap. And let's get it. Let's go. I like this one. Let's go right here. We got 5x minus 3 raised to the second power, and it's situated up at 25x squared minus 30x plus 9. Let's still do it. Let's still use it. 25x squared. I got 1, 2, 3, 4, 5, 6, 7, 8 M's in my bank account. You about to have 1, 2, 3, 4, 5, 6, 7, 8 homework assignments. Yeah. Alright, so let's go back. Same rules apply. 25x squared minus 30x plus 9. Let's still do our AC method. Why not? Let's break it apart. That's a big number, but hey, let's still multiply it. 25 and 9. We're not using calculators, so we're gonna split it in half. So your job, 25 and 9. You gotta do 9 times 5, which is your 45. So put your 4 up top, 5 below. 9 times 2 gives you 18. Now do 18 plus 4, 22. So we got 225. So if I rewrite this, that says x squared minus 30x plus 225. So what two numbers multiplied by each other to give me 225, but those same two numbers when added to each other gives me 30. We're not going to do 1 and 225 now. We got to go down the list. So let's try out 5. What happens if I do 5? 5 times what gives me 225? Let's break that apart. So 5, 225. Just so y'all see, we ain't using calculators. This is math class. We got to break things apart, man. So 5 goes into 22. Well, I know 5 is a factor of 5, 10, 15, 20. So that's 4. So let's put a 4 there. It's 20. Subtract that, you get 2, 5. 5 goes into 25. Alright, we're getting close. That's 5 and 45. So let's keep it going even further. Let's try out. Can we do 15? Is 15 one of the numbers? So 15 goes into 25. 15 goes into there. I got 7, 5. So 15, 30, 45, 15, 30, 45, 60, 75. Whoa. 15 gives me 30. 15 times 15, 225, so that's a perfect square. So boom, let's break that bad boy apart. We got x minus 15, x minus 15. Here we go, right in front of you. And now remember, take our 25 and we're going to reduce it. So we'll divide negative 15 on both sides by 25. What number goes inside both 15 and 25? We started it out earlier. What's the end number they both have in common is going to be a factor, which would be 5. 5 goes into 15, 5, 10, 15, that's 3. 5 goes into 25 5 times. So now we're going to attach our 5 to our x's. Ooh. Look at that. 5x minus 3. 5x minus 3. Let's crack it open. 5x times 5x is 25. X squared. 5x times 3, negative 15x. Negative 3 times 5x, negative 15x. Negative 3 times negative 3 gives us plus 9. And what do you know? How you like them apples? How do you like them apples? This is all you need to know. This is all you need to know. You get this starting point, you pass the test. And you can knock it all out. So our answer here is going to be factor 5x minus 3, 5x minus 3, or the best way, 5x minus 3 squared. And now we in business. Now we talking. Ain't got nothing to complain about. All right, I think let's stop there because we're about to run into an hour. So, I'm Mr. Jackson. This is Math Relation. If you enjoyed today's lesson, make sure you like, subscribe, hit us in the comments with what was hype about today's lesson. Tell us where you're from. Shout out your math teacher. Don't put too much smoke on our back saying like Mr. Jackson better than my math teacher. Those be flooding up the YouTube comments. Like, I appreciate it. I am better than your math teacher. Let's get it, boy. I'm about to rank your math teacher. Your math teacher can't teach like me. Your math teacher ain't look like. I'm having too much fun in front of this camera. Now I see why the kids be doing this in class. You just be vlogging while you're teaching. Let's make this a great year. We out. Peace out.